Today we'll talk about large-scale logging, how to make it easy, and which solutions exist on the market. Let's start. Let's start from the basics. What's logging? It's not this, but similar thing. The logging is just it's an example of some kind of logs, typical logs, and they contain usually with log lines, and every log line has timestamp usually. It has usually level, log level, and it can have additional fields such as log location in this case, or other fields. And another mandatory field is log message itself. It's just some kind of plain text. What's the purpose of the logging? To make paper? No. The first purpose of the logging is debugging. When you log some events in your application, then you can figure out which errors this application was generating at which time. You can debug why the application returns some unexpected response for some request. You can debug why application wasn't working for some period of time. And you can debug also what the application was doing at some period of time or some period of range. It's some kind of tracing. But by the way, tracing is also, I think that tracing is also a subset of logging. The second application of logging is security. When you log some kind of security events or audit logging, you can then answer such questions: who dropped your database in production, and when, who tried to log in as admin in your applications, who performed any action at any time, or how many failed login attempts were during some period of time. And the last application of logging is stats and metrics. When you log every request, for instance, in your web applications, then you can then answer such questions as how many requests were served per hour during the last day, for instance, or how many unique users were accessing your application during last month, or how many requests were served from the particular IP or IP range during some period of time, or which percent of requests were successful or unsuccessful during some time, or another application is what the 95th percentile of request duration was for the given web page for some period of time. That's three main purposes of logging. That's debugging, security, and stats. And traditionally, logging was used for the last 50 years or for more. I think that for since computers have been invented, logging was used. And the traditional logging was used for this during this time. And what's traditional logging is just save logs which generated by applications to a local file system, to local files. For instance, if you run Linux or Unix-like system, most of the applications, traditional applications, put logs into var log directory, as you can see here. It's from my laptop. And after logs are saved into these files, these logs can be analyzed with traditional command line tools, such as grep, cut, awk, sort, head, tail, less, and so on. Here is an example of how to use some kind of bash piping, bash foo, to get the top of applications which write logs into, which write the most of logs into var log syslog. And on my laptop, you can see that the most of logs are generated by kernel and dbus daemon. I don't know what is this, but some kind of dbus daemon. Okay. The advantages of traditional logging is it is very easy to use and operate and understand. You just write logs in plain text format into files, and that's it. And traditional logging is easy to debug and to reason about. If something goes wrong, you know where to search the problem. You just can investigate the file, investigate the configuration of your application, which runs, writes logs into local file system, and it's not too hard. Another advantage is for traditional logging is such logs is easy to analyze with command line tools, as I mentioned before. And these command line tools can be combined into pipes, Unix pipes, and into bash scripts, and even into some kind of scripts written in any other language, such as Python, Go, and so on. And traditional logging works for the last 5 years, at least for the last 5 years, since 1970s, when Unix has been invented. That's great. And what is the disadvantages of traditional logging? The first main disadvantage of traditional logging is that it is hard to analyze logs simultaneously from hundreds of different applications. Why this has been appeared? Such problem has been appeared because of Kubernetes and microservices, which are very hypey for the last decade. The second disadvantage of traditional logging is that you just need to scan all the log files when you need to debug something, to investigate something. And if these log files are very big, such as terabyte sizes, then it may take hours to get some information from these log files with traditional logs. Because 1 terabyte file needs at least 1,000 seconds for reading at 1 gigabytes per second speed, for instance. And the last disadvantage of traditional logging is imperfect support for structured logging, because traditional logging is usually used for just for unstructured logging, for plain text logs. And the solution for this problem is large-scale logging. Which core principles large-scale logging should have? You just collect logs from hundreds or thousands of your applications and push these logs into a centralized system for later analysis. Such system should provide fast queries over big amounts of logs. And it should support structured logging and search over structured logs for convenience. Which solutions do exist for large-scale logging right now? There are two groups of these solutions. The first group is cloud solutions, such as Datadog, Sumo Logic, New Relic, and so on. And the second group is on-prem solutions, such as Elasticsearch, OpenSearch, Grafana Logq, or Victorialogs. Let's compare these two groups from the operational complexity. The cloud solution is obviously very easy to operate because you don't bother about the operation of this solution, and the cloud provider operates it. And on-prem solution is harder to operate because you need to run this, set up this solution and run it, and then operate. What about security? Cloud solution is strange. It's questionable security because you push logs to some third-party provider, and this third-party provider says that, okay, I encrypt these logs and nobody has access to these logs, trust me. But I don't trust. And on-prem solution is much better from security perspective because you fully control all the logs you store in your local system. What about pricing at large scale? I mean, because at low scale, cloud pricing is quite low. And what about large scale? And cloud pricing is very expensive. I think that you heard the recent history about Datadog, when some of its clients paid them $65 million. So it may be very expensive at large scale. And on-prem solution pricing costs depend on the solution and on the setup of the solution. Let's talk about this right now. Let's compare 3 on-prem solutions for large-scale logging, which 2 of these solutions are very popular and known, such as Elasticsearch or OpenSearch and Grafana Loki. And the last solution is from Victorimetrics, which has been recently appeared, Victorialogs. Let's compare them. From the setup and operation complexity, Elasticsearch is hard to set up on large scale, or even on small scale for logging because of non-trivial setup for indexing on this Elasticsearch. If you use Elasticsearch for logs, you may know about this. I mean, if you use professionally and don't just blindly install Elasticsearch and forget about it. Grafana Loki is also hard to set up and operate because it has very non-trivial architecture with many microservices which are connected with each other. And these microservices have very complex configuration options, and it may be very hard to set up it properly and then operate it, upgrade, and so on. And what about Victorialogs? It's easy to run because right now it's just a single binary which runs perfectly with default configuration. You just run this binary and start using it. What about costs for large-scale logging? Elasticsearch costs are high because mostly of high memory usage and disk space usage. Elasticsearch has not so good compression for the stored logs, so that's it. Grafana Loki is better from the costs perspective because it compresses data better than Elasticsearch, but it has also high RAM memory usage, especially for high cardinality labels. And Victorialogs costs are low because it is very optimized for data compression. It compresses data 30 times better than Elasticsearch or Grafana Loki, for instance, and it uses much lower amounts of memory than Elasticsearch and Loki. So a single instance of Victorialogs can replace a big, large cluster with 30 nodes, for instance, of Elasticsearch or Loki cluster. You can go by this QR code and try running benchmark for Victorialogs on yourself and compare how it works comparing to Elasticsearch or Loki. What about full-stack search support? Elasticsearch obviously supports full-stack search, but it needs non-trivial configuration for indexing in order to work properly and fast. Grafana Loki also supports full-stack search, but it isn't optimized for it, and typical query with full-stack search can take a lot of time on large amounts of logs. And Victorialogs is optimized for full-text search, and full-text search works without any configuration. Contrary to Elasticsearch, you don't need to specify any indexing for any fields. Victorialogs indexes all the fields from structured logs, and allows you performing full stack search on all these fields. Let's compare how to efficiently query 100 terabytes of logs on these systems. For Elasticsearch, you need to have a cluster with around 200 terabytes of disk space and 6 terabytes of memory. According to the article from Elasticsearch, you can go to this article by scanning this QR code. And such big infrastructure would cost you around 50,000 euros per month on popular Google Cloud or AWS. What about Grafana Logq? Grafana Logq simply doesn't work on this scale, because if you try to query to find some data over 100 terabytes of logs in Grafana Logq, this query will be performed forever. I mean, it will take more than an hour or more than days, because of how Grafana Logq works. It just scans all this data, and 100 terabytes of data. In order to scan 100 terabytes of data, you need to spend a lot of time, even on 10 gigabytes per second read speed. And Victoria Logs is much more efficient on this scale. It can handle 100 terabytes of logs on a single node with 6 terabytes of disk space, because it compresses data much better than other systems, and with much lower amounts of memory. And such infrastructure will cost, obviously, much less compared to Elasticsearch, up to 30 times less. Let's talk about integration with command line tools, which are used in traditional logging. Both Elasticsearch and Grafana Logq has very poor integration. I would say they have no any integration, any good integration with command line tools. And Victoria Logs has excellent integration. You can go there and read documentation about how Victoria Logs integrates with command line tools. Victoria Metrics for large-scale logging satisfies requirements which we mentioned before. It efficiently stores logs from large number of distributed apps. It provides fast full-text search, and it supports both structured and unstructured logs. And additionally to this, Victoria Logs supports traditional logging features, such as ease of use and great integration with command line tools. And let's compare. Let's look at how Victoria Logs integrates with command line tools. Unfortunately, I couldn't connect to the internet, so a live demo will not happen. But fortunately, I prepared slides, backup slides for this. So let's look at these backup slides instead of live demo. Let's find error logs for the last hour, which generated by all the apps which store data to Victoria Logs. In order to get this information, you just query. You just need to query Victoria Logs with such simple query. This query is named Logq query. You can go by this QR code and read about Logq. It's the query language for Victoria Logs. It's very simple. This query contains two parts. The first part is filter on time. This part says that let's look at the logs for the last hour. And the second part is a filter on full text search filter. It just says, please return me logs which contain error report in these logs. When you combine both these filters, just type them with via space, you get all the logs which contain error word for the last hour from all the applications. And this is how how this query is executed in live demo. But live demo doesn't work, so let's look at it here. This command line bash script, vmlogs query, which contains just some kind of wrapper around curl command, which queries Victorialogs via HTTP API and passes to this query, to this command, this query, and then pipes this query via some bash, traditional bash commands such as head and GQ. And you, obviously you can use any bash command and any thing you can make in command line. For instance, you can save query results into file for later analysis, and Victorialogs actually can return you billions of matching log lines without any issues, and you can store these billions of matching log lines into file for later analysis. This is a response from Victorialogs. It contains JSON lines. Every JSON line contains log message, log stream. It's some kind of concept from Grafana Logq. Thanks Grafana Logq for inventing this concept, and Victorialogs reuses it, but more efficiently. And every log returned log result contains a timestamp for this log. Every log result can contain other log fields. If you request these log fields, you can scan this QR code and read how to work with this. There should be demo, but we have no internet. Let's go there further. As you can see from this screen, the response contains JSON lines, and it may be hard to read these JSON lines. What about when we need to just read only log message? That's no problem. You just use JQ. That's the traditional tool from command line. You just specify that let's return only message from every log line, from every JSON line, and you instantly get clear log messages without any other JSON fields. There should be demo. What about how to calculate the number of error logs during the last hour? Just use WCL, pipe log results to WCL, and you get the number of error logs during the last hour. What about understanding which applications generated the most of logs, error logs during the last hour? Then there is no any problems. Just use bash foo. Just extract stream field from every returned log line, sort the stream fields, stream values, and then calculate the number of unique values per each such line, and sort in reverse order these results and show the last 8 results, and you will get this nicely looking response, which contains stream values and the number of error logs for every such stream value. This means that the number of logs generated by every application, because stream log uniquely identifies a single application. There should be demo. From this screen, we see that the most of logs are generated by some kind of strange application, Fluent Bit GKA. Let's look at these logs. We just add the stream filter to the Logscale query. You can read about the stream filters by QR code. And that's it. You get only logs from this particular application. What about calculating some kind of stats? For instance, how many error logs were generated per every minute during the last 10 minutes? It also can be implemented very simple. Just pipe query results for the last 10 minutes into some kind of bash scripts which extract timestamp field and extract then minute parts of this timestamp field, sort them, and calculate the number of unique values, and you get per minute stats of raw logs for the last 10 minutes. Another example is how to calculate the number of logs which contain status equal phrase, but do not contain status equal to 100 phrase, because it's the most frequently occurred status, and nobody cares about successful responses. You just write this filter. You can scan QR code about and read how this filter works in Largescale query, and then pipe these results to some kind of bash scripts and get results. And you can see that the most of logs contain status 400, in this case for the last 7 days. What about IP addresses? Let's extract remote address value from IP addresses and get the number of stats about IP, how many log messages were generated by every IP address with status 400 and 404, for instance. You just write this Largescale query, add additional filters in order to filter out only log lines with the needed status values, and then pipe them to regular bash foo and get results. And you can see that the most of log queries were generated by a particular IP address. Let's look at this IP address more closely. For instance, let's look how many per day log lines were generated with this IP address. How many log lines contain this particular IP address for the last 10 days. No problem, just write this query, simple query, and pass this query results to some bash foo. And that's it, and you get per day number of log lines with this IP address for the last 10 days. That's another example how to query per level log level stats for the last 5 days. No, 7 days. It's an error here. You can just use a special function which means which is named in, and you can filter on a particular log field, such as level. You can see level colon in. This means that this query returns results only for log lines which do not contain level with info message. Here should be demo. Okay. So from these slides, you can figure out that large-scale logging must provide excellent command line integration, because otherwise it may be hard or impossible to perform such query examples I mentioned before. for instance, to implement to write queries or for these examples in Elasticsearch or Grafana Logq, and it will not be so easy. Oops, sorry, it's my daily thing. So how it looks, you start with file-based logging, then you discover Elasticsearch or Logq, and after that you discover Victoria Logs and understand that Victoria Logs is basically file-based logging on steroids. It is easy to use, it works on large scale, and it integrates good with traditional command line tools, like file-based logging. And if you don't like command line tools, then Victoria Logs provides also web UI, like Elasticsearch or Grafana Logq, and you can use this web UI. But obviously, this web UI doesn't provide integration with command line tools, so it doesn't allow you implement all this stuff which we were talking before. So Victoria Logs is good solution, but obviously it has some drawbacks. Let's look at the drawbacks. The first drawback is right now Victoria Logs doesn't have functionality for data extraction and advanced stats in Largescale. But it is planned in the future and will be implemented in the future. But right now you can use traditional integration with command line tools for calculating these stats and for advanced integration, data extraction. The second drawback is right now Victoria Metrics is only a single node version and doesn't have cluster version. We are going to implement cluster version in the future. But right now you can still use single node version of Victoria Logs and replace large clusters of Elasticsearch or Logq with single node Victoria Logs. And the last feature which is missing right now in Victoria Logs is integration with Grafana. But as you could see before, Victoria Logs already provides its own web UI, and we are going to make this web UI much more useful for typical use cases for logs in the future. So let's recap. Victoria Logs is easy to set up and operate. It's just single binary without any configurations. It uses much lower amounts of memory and disk space compared to Elasticsearch and Grafana Logq. It supports fast full text search over all log labels and log entries. It has excellent integration with command line tools for log analysis, and it accepts logs from all the popular log shippers which are in use right now, such as Felbit, FluentBit, Logstash, Vector, Promptail, and so on. And last not least, it's open source and free to use, so just try it. Here are documentation about Victoria Logs and documentation about Largescale query. That's all. So, questions?
Thank you, Aliaksandr. So, are there any questions right now? I have this wonderful box I could throw at you. Yes, right there. Can you catch?
Hello. Hi. So is the cluster version on the roadmap?
Yes, cluster version is on the roadmap, and we are going to implement it in the next year.
But in the meantime, there's no way to replicate the logging data, really?
No, there is a way for replicating the log data. Just push the same logs to multiple single node Victoria Metrics or Victoria Logs instances.
Thank you.
Anybody else?
Sure. No questions? Why?
Questions?
It's controversial thing. Ask questions. So
yes.
Is there a REST API to access the data?
Victoria Logq provides HTTP-based API. It's some kind of REST. You just can put data. You mean to access data? Oh, okay. Victoria Logq provides API for HTTP API for pushing data, which to Victoria Logq. This HTTP API is compatible with existing log shippers, so you can just push data via this API to Victoria Logq. And from the query side, Victoria Logq also provides HTTP-based API. You just send get query to Victoria Logq and get results. And all these command line tool examples in this talk were based on this curl command. No curl, just send curl requests to Victoria Logq and get responses from there.
Yes.
If I may.
Of course you may.
Hi. Could you expand on how data is enriched and normalized? I know how it works in Elastic. You would like normalize or enrich the data, send it, and in Logq you would just send it and then it's enriched later or normalized. How would that work here?
Victoria Logq doesn't provide any log shippers on itself. Probably we will create some great log shipper in the future, but right now it provides a good integration with existing log shippers, which can enrich data, transform data, filter this data, for instance, Logstash. So you can just enrich, transform, filter this data on Logstash, and then forward this data already enriched and transform it to Victoria Logq.
Anybody else? Okay, thank you again, Aliaksandr.